Hello and welcome to the Wired Lab video tutorials. My name is Hannah Jacobs and I am the Multimedia Analyst for the Wired Lab. In this tutorial, you will learn how to add geographic information to an image, making it possible to layer it on top of interactive web maps such as Google or OpenStreetMaps. The content in this video is also explained in a written tutorial that you can find here or in the description below these videos. If you'd like to follow the text in this video, please make sure you've turned on closed captioning. This video uses QGIS version 2.14 on a Mac operating system. However, these instructions should be compatible on Windows and with QGIS versions as new as 2.18. Let's get started by opening QGIS. Go up to Finder, File, open a new Finder window, and navigate to Applications. You should find QGIS in your list of applications. Double-click to open, and you can close the Finder window. We'll begin with OpenStreetMap. So I've opened OpenStreetMap, and notice it's added a new layer to my Layers panel, and it's also loaded open layers into my viewer in the main panel. We'll go ahead and zoom in on the area that we need. For this tutorial, we're going to be focusing on Venice. So I'm going to go up to the top toolbar and notice we've been working automatically in this hand tool, which lets us move the map around in the space. And each time we move the map, notice that a blue bar appears and the map reloads. Anytime the map is slow to reload, make sure that you see that blue bar, and that will help you know that QGIS is simply updating what you see and pulling additional layers down from the web. So let's grab the zoom in magnifying glass with the plus sign and hover over the area roughly where Venice is, so we'll start with Italy. And each time we click, the Open Layers plugin has to reload the map. So here's the area that we're going to be working with, Venice, and we've got a pretty good look at it. You should find here a link to the tutorial, duke.box.com/v/oogie. So this is a historic map of Venice, and you'll see that the general shape of the city is very similar, right? This is an 18th century view, and very little has changed as far as the overall structure of the city is concerned. Now if we look at this and then scoot back to QGIS, there may be certain things that you notice that have been added. Let's download our file, and I'm going to download it and save it to a new file that I will create on my desktop. So while that's downloading, I'm going to close this and on my desktop create a new folder that I'll call Georectification. As part of this process, we're going to have to create multiple files, so it will be important to keep them all together and know where they are. So then in your Finder, you should find that file in your downloads, tutorial Oogie Map Low Res. Pull that into this file folder where I will be keeping all of the image files and data files that I create for this tutorial. So now I'll close the Finder window and return to QGIS, and let's open up our historical map in QGIS. We could, in theory, navigate in the browser panel to that file folder that we just created. Here it is, Georectification. And we could grab that image file and drop it into our Layers panel. If we did that, we would find, if we right-click and click Zoom to Layer, that the file has been added to OpenStreetMaps, but it will come up automatically in the wrong location, and I will zoom out just to make the point. And what you should find is that it's actually been added at the point where the prime meridian and the equator meet off the west coast of Africa. This is not the correct location for this map. What we need to do, in fact, is add the image over Venice and attach points that match points on the map to points on the image. So in order to do this, I'm going to remove this by right-clicking and looking for Remove. So I'm going to select Georeferencer under Raster Georeferencer, and that's going to open a new menu. To add the raster into our new window, we'll go up to the blue Open Raster checkerboard icon and look for that image file and click Open. Now, you'll always receive this pop-up window when you add a new layer into QGIS. It's asking you to select a coordinate reference system. For this map, we want to make sure that we match the coordinate reference system to the reference system that OpenStreetMaps uses. So we're going to choose WGS 84 Pseudo Mercator EPSG 3857. When you're sure that that's been selected, click OK, and your map will be added. Now we can begin to add points to our image map and match those points to locations on the OpenStreetMap. So I'm going to actually go back to QGIS for a moment, and I will make this window a little bit smaller so we can always find the georeferencer. And now I need to refocus back on Venice because I've taken us out of there. And for now, I'll leave it at this scale because we want to be sure that we can see the entire extent of Venice. So comparing this map to what we see in the OpenStreetMap, you should notice that you have an overall fish-like shape of the city. For a moment, I'm going to zoom in on this bottom string of islands known as the Giudecca, and I'm going to use that as the starting point for adding these points for the georeferencer. So in the georeferencer window, and again, make sure you have your windows set up so you can find both. I want to make sure that I have this tool that looks like an airplane with a yellow snowflake selected. That is the Add Point tool. So now, if I click anywhere on the map, I will automatically add a point to the image. But before I do that, I want to zoom in just a little bit further on my map. The further zoomed in you are, the more accurate your placement of points will be. So it's important to spend time zooming in and getting a good view on the area that you're going to be mapping. So that's roughly the same scale. I will return to that Add Point icon, and I'm going to start with this point here at the end of the Giudecca. I'll click once, and a window has popped up called Enter Map Coordinates. If I knew the exact map coordinates for this point on the island, I could add those in by typing or copying and pasting, but because I don't, what I'm going to do is click From Map Canvas over here on the left, and that will automatically hide the georeferencer window and return me to the QGIS window, where I can now click on that corresponding corner and notice the georeferencer window has popped back up and the Enter Map Coordinates window has also reappeared, and now there are coordinates listed in the two text boxes for the latitude and longitude. I'll click OK, and you should see that a red dot has been added on the georeferencer map, and a red dot has also been added on the OpenStreetMap. If we look at the bottom of the georeferencer, we should also see the beginning of a table. This is the data for that point that matches this location on the image to this location on the OpenStreetMap. So now what we need to do is repeat this process several times. 5 to 10 is recommended in order to match this image to what we see on the OpenStreetMap. It's a good idea to try to use features on the map that we know have not changed between when the map was made and present day. So these could include streets, buildings, or shorelines. So I will continue this process. Feel free to follow along and use the same locations that I use here. So now I have 6 points that are scattered across the city of Venice that I am relatively sure have changed very little over the last 200 to 300 years. And we should see 6 red points that match the points that I've identified on the image in the OpenStreetMap. We should also have a row of 6 different points listed in the table below the georeferencer. To continue, we need to set up a few parameters for adding the image to the OpenStreetMap. So we'll look for the settings button, the transformation settings, it's a yellow cog, and open that menu. We have a number of different kinds of settings that we need to check. The first is transformation type and resampling method. These are different algorithms that QGIS can use to match the image to the points that we have identified on OpenStreetMap. The different algorithms will apply different kinds of transformations to the points. Some will stretch the image more than others. In this case, we have a lot of textual information on this historic map that we don't want to become distorted in this process. So we want to use an algorithm that we know will be as accurate as possible without actually changing the shape of the image. So in this case, I will choose Helmert for the transformation type and try linear for the resampling method. Target SRS. This needs to be the same coordinate reference system as we chose when we added the file into the georeferencer. So look for EPSG 3857 WGS84 pseudo Mercator. Then under output settings, we need to give an output location and file name for output raster. QGIS is very helpful in that it adds modified at the end of the file name. So we'll just stick with that, make sure it's in the Georectification folder and click Save. And finally, you want to be sure that the checkbox next to Load QGIS when done is checked, and that way when the georectification process has been run and completed, the map will automatically be added as a new layer in QGIS. So click OK, and the next step is to start the georectification process using the Start Georeferencing button. It looks like a green play button. When I click that, you should see a progress bar appear. This should go relatively quickly for this file. Larger files may take longer. The more points you have may also increase the load time. So now if we switch back to QGIS, here we should see our map. And notice it's been turned slightly. And the reason it's been turned is the algorithm is trying to match the image, as we mentioned before, to those points that we identified. And in so doing, it's realized that Venice as a city needs to be turned slightly in the image to match what's shown in OpenStreetMaps. In order to see this, let's right-click on our layer over here in the Layers panel and navigate to Properties. And in Properties, look under Transparency. And where it says Global Transparency, turn the transparency up to about 50% and click OK. And now you should be able to compare the image file on top to what's underneath. If you're satisfied with that, you can move forward with this tutorial. If not, remove your georeferenced layer, return to the georeferencer. You can remove these points or add more points, and then run the georeferencing process again. Just for a reference, if you need to, you can add more points with the airplane with a yellow snowflake add point icon. You can delete points using the red X airplane icon, and you can move points with the blue arrow airplane icon in the georeferencer. I'm happy with what I've done, so I am going to close the georeferencer window, and it's going to ask me if I want to save these points. Just for now, I will go ahead and save them in case for some reason I need to come back and run the georeferencing process again. And this should automatically save them in my Georectification folder along with what I now have are two different files. So notice I have the original file, which is saved as a JPEG. Then I have this modified TIFF file, now a GeoTIFF, not simply a TIFF image file. And then I also have this .points file, which is just the data for those points in reference to the JPEG image. Returning to QGIS, I could be happy with this image and I could export it out and now use it in any number of web platforms. However, I do want to pause and actually make one modification. So if I go back and return the map to full opacity and click OK, notice that there are large black borders that have been added around the edge of the map in order to keep the file image rectangular for the TIFF file format. This is fine, but I would actually prefer this area to be transparent so that we can see as much of the base map as possible. In order to do this, we can minimize QGIS and open up an image editing software. In this case, I'm going to work with Photoshop. And these instructions are going to be given in Photoshop Creative Cloud 2017, but they should work similarly in earlier versions of Photoshop. Okay, in Photoshop, navigate to Open or File Open and look for that modified TIFF that we created. There we go. And click Open and make sure that you can see the layers in Photoshop. So it automatically comes in as a background layer, but what we're going to do is duplicate that layer. And you can give it a new name if you want. And then we are going to unlock the background layer. So now we have two unlocked layers, one on top of the other, the same map file. Now that the background layer, now layer 0, has been unlocked, navigate to opacity and set it to 0% for that layer. And then select layer 1, which is the top layer that we see in Photoshop. In the left-hand toolbar, select the lasso tool and click and hold to see the different lassos that you can select. We want the polygonal lasso tool in this case. And we can now use this lasso tool to select all of the black space that we don't want and remove it to create transparent space. Again, it may be helpful to zoom in here in order to be as accurate as possible and in order to avoid clipping the map. You can use Command plus to do this as you work, or the scroll bar. So click once with your cursor to add a point for the lasso tool, and then click again to set your first line segment. Move your mouse, click to set another one, and continue. And as you work, you can zoom in and out automatically. And the zoom will go to where your cursor is located. So move your cursor and then zoom. And when you are about to complete, you should see a little circle appear next to your polygonal lasso tool. Now I'll click, and I should get a nice dotted line, and I should be able to now press the delete key and remove that added black space. So now I'm going to repeat the same process for the other three sides of the map. Right. So now we have that transparent space added. We can navigate to File, Save As. We still want to save it as a TIFF, but this time we want to again make sure that we save it as a new version so as not to modify our modified TIFF file. So I'm going to add an underscore PS to note that it's been through Photoshop. Click the Save button. And in TIFF options, make sure that Save Transparency has been checked. And Adobe Photoshop may give you a warning about this. Just click Yes. Then click OK. And if it gives you another warning about increasing the file size, click OK. And now that should be saved. Now, in our Georectification folder, we have three different image files. The original file, the GeoTIFF that we created just now that has the black edges around it, and the modified Photoshop file. Now this is still a TIFF file, but it's actually not a GeoTIFF anymore. When you add a TIFF into Photoshop that is a GeoTIFF and then modify it and save it, Photoshop is going to strip out all of the geographic information, so reverting it to a regular image TIFF file. So now what we have to do is go back into QGIS and georeference this image to our original layer file. So return to raster georeferencer, load up that modified PS TIFF file, make sure that we've chosen the correct coordinate system, click OK, and now we can just use the corners of this map layer to match it to the corners of the layer that's still shown in QGIS. So I'll just add all four corners here using the exact same process we did before. And then I'll navigate to the transformation settings again. And this time the transformation type needs to be linear, and the resampling method also needs to be linear. This will ensure that the map doesn't shift in any way and stays in line with the original GeoTIFF. So let's make another output raster file, and rather than calling it modified PS modified, I'm going to call it web. So I'll click Save and load in QGIS when done. Make sure you double check that selected CRS to make sure it's correct, and click OK and play. The georeference was successful, so I'm going to minimize the georeferencer. And now we do have two layers shown here, but we actually are seeing one underneath the other. So let's uncheck our modified original GeoTIFF so that we can see our complete GeoTIFF here. And if you want to, open up that Properties menu and turn on a little bit of transparency so you can compare the image that we have here to the OpenStreetMaps beneath. I have chosen a file in this case that I know will georeference relatively easily to OpenStreetMaps because of the file's accuracy. However, this may require, for some images, a fair amount of study and time spent adding points, moving the points around, testing out different transformation and resampling algorithms in the transformation settings. So be patient with this and try different methods. As you work through this, just make sure that you document for yourself which transformation settings work best and where your points are, so that you do not have to repeat this process later if you lose a file. So now we are ready to export this for the web. Let me return this to full opacity. I'm going to right-click on this layer and navigate to Save As. Make sure that it says GTIFF, and the output mode should be rendered image, and go to Browse. And again, we may need to add another image name so that we have all of the correct names. In this case, I'll just add ready so that I know that for sure it's web ready. Click OK. Check that our CRS is correct. Notice that it's automatically changed it to the wrong CRS in this case, so make sure that we set it back to our layer CRS, which should be 3857, pseudo Mercator. Click Layer Extent to make sure that the bounds of the layer apply only to the image file and don't try to bring in all of that OpenStreetMap. And then click OK. And it's going to save the raster for us. And this should be your final raster that you need in order to upload and add it into a Neatline project or Carto or StoryMap.js. Now the step in between is to use a GeoServer or a service like Mapbox to host the image. For a course at Duke, we ask that you rename your file, adding your last name to your image file that's ready to go. So I'll add my last name. And then we will send you a box link or a Sakai link that you can use to upload your image. We will then add your image file to a GeoServer. We use GeoNode at Duke. And we'll send you instructions for adding the WMS address and layer information into your Neatline or StoryMap.js or Carto project.